Hello everyone, welcome to VCIA training course. The theme of this course is PON and 10 GPON principles. This course includes the following content. I wish that by the end of the course, everyone can understand the basic concepts and working principles of PON. Now open the first chapter. This chapter introduced the composition, advantages, and development history of PON. It can be divided into 4 parts, which sequentially introduce the advantages of optical fiber access, different schemes for optical fiber access, typical product forms of PON, and the development history of PON. Compared with XDSL access mode, optical fiber access has the following advantages. The transmission medium cost of optical access network is decreasing. The optical fiber is a non-metallic conductor, which is free from lightning and electromagnetic interference. And the cost of line operation and maintenance is low. The optical fiber is small in volume, light in weight, and easy to lay. And the key is that PON can provide higher bandwidth to meet the needs of HDTV services. These are 3 access schemes for optical fiber access networks. The first solution is that the transmission cost of peer-to-peer networks is too high and wasting fiber resources. The second solution is that optical fiber to roadside switches reduces transmission costs, but adds live equipment on the access side, increases fault points, and also increases maintenance costs. However, when passive optical networks adopt point-to-multipoint mode, it not only reduces transmission costs, but also avoids the increase of access side fault points. The third option is what we commonly call PON. Now let's understand the composition of PON networks. This is its typical network. PON networks can transmit voice data, network data, and video data. Among them are optical line terminal, abbreviated as OLT, optical distribution network, abbreviated as ODN. It consists of optical fiber and PON splitter, abbreviated as POS. Optical Network Unit, abbreviated as ONU. Or it is an Optical Network Terminal, abbreviated as ONT. There are 2 organizations that develop PON standards, IEEE and ITU. IEEE has developed the EPON standard, the 10 GPON standard, and the NGPON standard. ITU worked at PON earlier and developed many standards. Standards like EPON and BPON are outdated, and GPON is popular now. XGPON, XGS-PON, and NGPON2 are gradually becoming popular. From this, we can see the development process of PON and the increasing. This chapter introduces multiple key technologies of PON. PON transmission principle, optical burst switching, ranging, and PON protection in turn. And there are various types of PON protection. Only Type B is introduced here. And these technologies are key technologies for PON, widely used in EPON, GPON, 10 GPON, and XGS-PON. Now, let's consider the first question. How to send and receive simultaneously in a single core optical fiber. The method is to set the optical carrier signal sent and received by the device to different wavelengths. As in the figure, the wavelength of optical signal sent by OLT to the ONU direction is 1490 nanometer, and in the other direction is 1310 nanometer, so that they will not affect each other when working on the same fiber. The combination of two or more different wavelength optical carrier signals into a single core fiber, so that it can reuse different wavelengths of laser, is wavelength division multiplexing, abbreviated as WDM. Now let's learn about the transmission method of PON. In downstream, it is broadcast mode. Through the schematic diagram, we can analyze all ONU can receive the same data. The data of different ONUs is distinguished through different identification methods. In EPON, it is LLID, in GPON, it is GEM-port ID. ONU receive their own data through filtering. In upstream, it is TDMA mode. The upstream link is divided into different time slots. The upstream time slots are allocated to each ONU according to the upstream bandwidth map field of the downstream frame. Now, let's consider the second question: how to ensure that the optical carrier signals sent by each ONU to the OLT do not overlap or affect each other on the main fiber? To solve this problem, PON uses two key technologies: optical burst switching and ranging. The characteristic of optical burst switching technology is independent transmission of data packets and control packets. It adopts a unidirectional resource reservation mechanism with optical bursts as the smallest switching unit, as shown in the following image. For ONU, this means that its PON can only send laser within a fixed time slot. So ONU always suddenly sends laser and then turns off. If there is an ONU that is not in its own time slot but produces laser, it will affect the work and even registration of other ONUs under the same PON port. This type of ONU is what we call rogue ONU. We all know that in reality, the distance from each ONU to the OLT is not exactly the same. It may be a bit closer or a bit farther, so the time required for them to reach OLT is also different. This technology is ranging. OLT can measure the distance from each ONU to it, then perform calculations and delay compensation, and allocate time slots to ONUs to ensure that there is no data conflict in the upstream direction. PON protection is a type of redundant protection aimed at improving the reliability of PON networks. It has many types of PON protection, and Type B protects the backbone fibers in the PON network. As shown in the figure, the OLT has two PON interfaces connected to the same batch of ONU. These two PON ports, one in working mode and the other in backup mode. Once the connected backbone fiber is disconnected, it will be transferred to another port for operation to ensure that the network is not affected. Therefore, this will greatly improve the stability of PON network. The third chapter introduces the basic concepts, important parameters, and working principles of EPON technology. This chapter includes the following content: providing a brief introduction to the performance and working protocol of EPON. This is the EPON basic information, including standard protocol names, rate, maximum spectral ratios, maximum distances, and wavelengths in different directions. Through these parameters, we can understand the basic capabilities of EPON. We will also compare it with other PONs in the future. Now, let's learn about ONU registration process. Step 1. OLT notifies ONU of the period of discovery window by broadcasting a discovery gate message. From this message, we can see the destination MAC is a multicast MAC. Send to the entire ONU domain the content. If you are registered, do not send data. If you have not registered, please register within a certain time. ONU receives this message and tells OLT its status. For example, if ONU online, it will say I've already registered. I'll keep quiet. If ONU offline, it will say I want to register. So, Step 2, ONU sends the registration request message with MAC. OLT learns from ONTS MAC, allocates an LLID, and sends it to ONU. So, Step 3, register ONU, assign and make LLID, finding MAC and LLID. For example, ONUA assign LLID is 10 and ONUA will save it. Step 4, OLT send a confirms gate message to register ONU whether LLID is correct. Step 5, ONU confirms its LLID and tells OLT with ACK message. Like the ONUA say my lid is absolutely right, over. The above is a complete registration process. Network management is usually divided into three categories: operation, administration, and maintenance, referred to as OAM. Operation mainly completes the daily network and business analysis, prediction, planning, and configuration. Maintenance mainly includes the daily operation activities of network and business testing and fault management. The interaction steps between OLT and ONU are as follows. 1. ONU goes online, interacts OAM messages with OLT, and completes the registration process. 2. OLT sends terminal configuration and management information to ONU through OAM channel. 3. ONU reports status and alarm information to OLT through OAM channel. VSOL EPON OLT can be divided into Layer 2 OLT and Layer 3 OLT. Layer 3 OLT has routing function and other rich functionality. In the Layer 3 OLT, we have 4 types of models: 2-PON, 4-PON, 8-PON, and 16-PON. The specific parameters of OLT can be obtained through our website or publicity materials. VSOL EPON OLT has been sold to many parts of the world. High cost performance and stable performance, which is a good choice. The 4th chapter introduces the basic concepts, characteristics, and application scenarios of GPON technology. And this chapter includes the following content: providing a brief introduction to the performance and working protocol of GPON. Firstly, this is the basic information of GPON. We can see that, except for using the same wavelength, the other parameters of GPON are different from EPON. GPON is superior to EPON in terms of speed, spectral ratio, and transmission distance. Then let's see the process of registering ONU on GPON. The standard protocol establishes 7 registration states for ONU, among which the first 5 states are involved from discovery to completion of registration. Initial state. O1. The ONU powers up in this state. Loss is asserted. Once downstream traffic is received, loss and LOF are cleared. The ONU moves to the standby state. O2. Then, in standby state, O2, downstream traffic is received by the ONU. The ONU waits for global network parameters. Once the upstream overhead message is received, the ONU configures some parameters and moves to the serial number state. O3. By responding to the serial number requests sent out by the OLT, the ONU makes itself known to the OLT and allows the OLT to discover the ONU's serial number. Once the ONU has responded to a serial number request, it waits for the unique ONUID assignment from the OLT. The ONUID is assigned using the assign _ ONUID message. Once assigned, the ONU moves to the ranging state. O4. This equalization delay is measured when the ONU is in the ranging state. Once the ONU receives the ranging time message, it moves to the operation state. O5. Once in this state, the ONU can send upstream data and PLOAM messages as directed by the OLT. Meanwhile, it represents that ONU has been registered and launched. And we can observe this status on the ONU web. Now, let's see the service mapping of GPON. This requires understanding the roles of TCONT and GPON. TCONT is a carrier for carrying services in the GPON upstream direction. All GPONs need to be mapped to TCONTs. TCONT is the basic control unit of upstream service flows in GPON. Each TCONT is uniquely identified by an alloc ID. The alloc ID is globally allocated by the OLT. GPON is the smallest service bearer unit in the GPON. All services are encapsulated in GEM frames and transmitted on GPON. The services are identified by GEM ports. Each GEM port is identified by a unique port ID, which is globally allocated by the OLT. Let's sort out the GPON business model. One ONU can mapping multiple TCONT. One TCONT can mapping multiple GEM port. One GEM port can mapping multiple VLAN service. It is worth mentioning that different TCONT can bind different DBA profile. Different GEM port can bind different traffic profile. For the DBA profile is bound on T contracting. OLT can dynamically adjust bandwidth allocation for uplink data through DBA to improve bandwidth utilization. DBA contains 3 different types of bandwidth for different purposes. They are fixed bandwidth, assured bandwidth, and maximum bandwidth. Fixed bandwidth means that it is allocated to the bound ONU TCONs and cannot be shared with other TCONs. Suitable for businesses that require high service quality, such as TDM and VoIP services. Assured bandwidth means that this T-contracting has priority access to this portion of bandwidth. When T-contracting requires bandwidth, OLT will adjust and meet the bandwidth guarantee requirements. When the traffic of the TCONs is not as high, OLT will adjust the remaining bandwidth and share it with other TCONs for use. The maximum bandwidth means the maximum bandwidth enjoyed by this T-contracting. Of course, this is the bandwidth that can be shared, but the minimum speed cannot be guaranteed. Then, by combining three different bandwidths, GPON OLT has 5 types of dBA profile. Type 1 only has the fixed bandwidth, while Type 5 can be configured with 3 modes of bandwidth. Assuming we set the 3 bandwidths to X, Y, and Z. Please note that the maximum bandwidth setting should be larger than the other bandwidth. The maximum bandwidth obtained by T-contracting is shown in the table. So everyone needs to configure the dBA profile reasonably. Now, let me give an example. If ONU bind this dBA profile, fixed bandwidth allocate 10 million bits per second bandwidth to this ONU owned by itself. This 10 Mbps bandwidth cannot be used by other ONUs. Assured 20 Mbps bandwidth to this ONU, it can be used 20 Mbps by itself. If this ONU is not used or less than 20 Mbps, other ONUs can use its remaining bandwidth. If the network bandwidth is sufficient, it can be used up to 50 Mbps. But this cannot be guaranteed, depending on the remaining bandwidth of the current network. Please note that under the same PON port in OLT, the sum of all fixed bandwidth and assured bandwidth in all ONU-bound dBA profiles cannot exceed the total bandwidth of the PON port, regardless of whether the ONU is online or not. When OLT discovers that the newly added dBA profile will exceed the bandwidth of the PON port, the configuration will be refused to take effect. Previously, we mentioned that EPON is managed through OAM. In GPON, it is managed through OMCI. OMCI is a protocol defined in the GPON standard for information exchange between OLT and ONU. OLT uses it to manage ONU in GPON networks, including configuration management, fault management, performance management, and security management. OMCI runs through GEM connections and is an asynchronous protocol operation protocol. EPON and GPON application comparison. EPON standard is made by IEEE, GPON standard is made by ITU-T. EPON, the maximum downstream rate and upstream rate are 1.25 Gbps. GPON, the maximum downstream rate is 2.488 Gbps, upstream rate is 1.25 Gbps. EPON, maximum splitter ratio is 1:64. GPON maximum splitter ratio is 1:128. EPON and GPON use the same wavelength. EPON QoS is good, but only Ethernet mode. GPON QoS is very good, including Ethernet, TDM, ATM. Through previous research, we have gained an understanding of the relevant knowledge of GPON. Now let's take a look at the types of VSOL, GPON OLT. All GPON OLTs of VSOL are Layer 3 OLTs that support multiple functions. In 2023, VSOL launched a single-port GPON OLT, a single-port GPON OLT with 32 splitters, and two-PON port GPON OLT. The specific parameters of OLT can be obtained through our website or promotional materials. This chapter introduces the basic concepts of 10 gigabit EPON technology, compares its parameters with EPON, and proposes coexistence solutions, which will help you understand 10 gigabit EPON. This is the table of contents information for this chapter. After a brief understanding, let's continue. The protocol of 10 gigabit EPON is IEEE 802.3 AV, established in September 2006, which expands upload and download bandwidth and supports a 1:256 spectral ratio. This protocol defines two types of 10 gigabit EPON technologies. One is asymmetric, with a download rate of 10 Gbps and an upload rate of 1 Gbps. The downstream center wavelength is 1577 nanometer, and the upstream center wavelength is 1310 nanometer. Another type is symmetrical. Both upload and download speed is 10 Gbps, a downstream center wavelength of 1577 nanometer, and an upstream center wavelength of 1270 nanometer. Meanwhile, IEEE 802.3 AV also supports 10 gigabit EPON ONU and EPON ONU to work under the same ODN. Through the comparison of this table, we can see that compared to EPON, the bandwidth of 10 gigabit EPON has been well expanded. The upstream wavelength range of asymmetric 10 gigabit EPON is consistent with EPON, and the upload rate is also the same, only 1.25 gigabit. The maximum spectral ratio of both types of 10 gigabit EPON reached 1:256. WDM and TDMA are key technologies for the coexistence of 10 gigabit EPON ONU and EPON ONU. Downstream use WDM to transmit both 1490 nanometer and 1577 nanometer wavelengths simultaneously. Upstream uses TDMA and accepts data packets from 10 gigabit EPON ONU and 1 gigabit EPON ONU. As shown in the picture, both 1 gigabit and 10 gigabit have their own wavelength ranges for upstream and downstream. And what we need to remember is the value of the central wavelength. The upstream of 1 gigabit is 1310 nanometer. The downstream is 1490 nanometer. The upstream of 10 gigabit is 1270 nanometer, and the downstream is 1577 nanometer. Based on our previous understand of 10 gigabit EPON, let's now take a look at the types of VSOL 10 gigabit EPON OLT and ONU. This OLT device is also the Layer 3 OLT with 8 PON ports, support the coexistence of EPON ONU and 10 gigabit EPON ONU. The uplink interface supports optical and electrical ports, gigabit and 10 gigabit SFP module, and has 2 ports that can support up to 100 gigabit. This ONU device has multiple interfaces, including one 2.5 gigabit LAN port, 3 1 gigabit LAN ports, 1 POTS port, and 1 USB v 3.0 port. It also supports Wi-Fi 6. AX 3000. The specific parameters of OLT and ONU can be obtained through our website or publicity materials. This chapter introduces the basic concepts of XGS-PON technology, compares its parameters with GPON, and proposes coexistence solutions, which will help you understand XGS-PON. This is the table of contents information for this chapter. After a brief understanding, let's continue. XGS-PON is an enhanced next-generation GPON technology. It solves many problems in GPON networks. It can meet the growing bandwidth requirements, support a 1 to 256 split ratio, and have longer transmission distances. ITU-TG987 is the protocol of XGPON, while ITU-TG9807.1 is the protocol of XGS-PON. XGPON is asymmetric, with a downlink rate of 10 Gbps and an uplink rate of 2.5 Gbps. XGPON is symmetric, both uplink and downlink speeds of 10 Gbps. The downlink center wavelength of 10 gigabit GPON is 1577 nanometer, and the uplink center wavelength is 1270 nanometer. Through the comparison of this table, we can see that compared to GPON, the bandwidth of XGS-PON has been well expanded, and the center wavelengths of the uplink and downlink are also not consistent. The theoretical transmission distance of two types of 10 gigabit GPONs reaches 100 kilometers, and the maximum spectral ratio reaches 1 to 256. From the information in the previous table, we know that XGPON and XGS-PON ONU both use the same wavelength. The standard of XGS-PON default supports mixed access of XGPON and XGS-PON ONU. The wavelength used by XGS-PON is different from GPON. In order to allow XGS-PON ONU and GPON ONU to coexist, two commonly used technologies will be introduced here. Option 1, WDM1R. The backbone fiber of GPON port and XGS-PON port is connected to WDM1R, which transmits the combination of GPON wavelength and XGPON wavelength to ODN for coexistence. Next is the second technology. Option 2, Combo PON. Combo PON supports two PON technologies through one combo port, so that one PON port supports multiple ONU types at the same time, building the hybrid network construction of GPON and XGS-PON. Based on our previous understanding of XGS-PON, let's now take a look at the types of VSOL XGS-PON OLT and ONU. Both OLT devices, as shown in the figure, are Layer 3 OLTs. The first OLT has 8 PON ports and supports the coexistence of GPON ONU and XGS-PON ONU. The uplink interface supports optical and electrical ports, as well as gigabit and 10 gigabit SFP modules, and has 2 ports that can support up to 100 grams. The second OLT has 2 PON ports and supports 2 working modes, XGPON and XGS-PON, but does not support coexistence. The uplink interface supports optical and electrical ports, as well as gigabit and 10 gigabit SFP modules. This ONU device has multiple interfaces, including one 2.5 gigabit long port, 3 1 gigabit long ports, 1 POTS port, and 1 USB v 3.0 port. It also supports Wi-Fi 6. AX 3000. The specific parameters of OLT and ONU can be obtained through our website or publicity materials. Let's continue with the last part, PON-related tips. This chapter describes other knowledge related to PON technology. This is the table of contents information for this chapter. After a brief understanding, let's continue. These are 3 types of fiber connector: SC, LC, FC. Their model is shown in the figure. We often use SC, which can be divided into 3 types: APC, UPC, and PC. We can see that their incisions are different from the picture. The performance comparison is APC more than UPC, UPC more than PC. From the table, you can see that there are various kinds of splitters with different splitting ratios. After splitting, the optical power will be reduced. For example, the old PON module send optical power is 5 dBm. When we uses 1:64 splitting ratios, the optical power will be 14.5 dBm. In addition, some devices will cause line optical attenuation. For example, every kilometer of fiber causes 0.36 dBm attenuation. Fervor connection and flange connector, and so on. There are 2 kinds of common optical splitter. The one is 1:n, another is 2:n. 2:n optical splitter, as we mentioned earlier, it is used for optical line protection. BOSA is a bidirectional transceiver device suitable for ONU application. The device consists of a transmitter, a receiver, WDM filter, and a single-mode fiber pigtail. The BOSA is directly packaged on the ONU device, and the optical module is not needed on the ONU. VSOL ONU using pigtail-type BOSA. EPON optical module common types are PX20+ and PX20++. GPON optical module common types are Class B+ and Class C+. Please refer to the data listed in the table for specific parameters. Ten gigabit EPON optical module common types are SFP plus PRX30 and SFP plus PRX40. 10 gigabit GPON optical module common types are SFP plus N1 and SFP plus N2. Please refer to the data listed in the table for specific parameters. That's all for this course. Thank you for your attention and listening.